Hello and welcome to the Calculator Guide video on essential GCSE Maths calculator skills. We're going to be going through a series of GCSE Maths exam style questions in this video. I'm going to be using an FX83 or 85 GTCW model calculator. You might have this model of calculator or similar. Additionally, some of these features may be available on previous Casio models, just in a different location. And lastly, these are not the only methods for solving these particular questions. You may know different methods or even be able to solve it without a calculator. These are just methods that I think are quite efficient ways of using the calculator to help you in the exam. So let's get started. First question here, arrange the following numbers from smallest to largest, and we have the numbers here. And once again, maybe you are able to do this without the calculator, but I'm just going to show you a method using the calculator that helps you sort these into ascending order. From the home page, go to statistics, and I'm going to select one variable because I've only got one set of numbers. If you have the frequency column on, that should automatically populate with 1, so let's just ignore it. And I'm going to input the numbers here, 0.42 and so on. Just take your time with all of these to ensure that they are inputted accurately. Once you've inputted those there, press Tools, down to Sort, and then we want smallest to largest, so it's X ascending, and there we have them sorted in order for you, starting with the smallest and ending with the largest, just in case you weren't sure. 126 as a product of its prime factors, and then part B, find the highest common factor of 126 and 216. So we can use the calculator to break a number into a product of its prime factors. From the home screen, we want to choose Calculate. And then we want to input our target number, in this case 126, and press Execute. And then we want Format, and down to select Prime Factor. And here you can see it in prime factor form. For part B, find the highest common factor of 126 and 216. Well, there are several different ways I will show you of being able to use the calculator to help you with this. If you want a fuller method, what we want to do is to find out what prime factors these two numbers have in common and then multiply them together to find the highest common factor. So at the moment we have 126 is 2 times 3 squared times 7. Let's break 216 down as well. Press Execute, and then we want prime factor. We have 2 cubed times 3 cubed. What do they have in common? They have 1, 2, and they have 2, 3, so 3 squared. So 2 times 3 times 3 equals 18. So the highest common factor of 126 and 216 is 18. There is another option that you have on this calculator to be able to find that. In Catalogue, you can select Numerical Calc, and then the way that it's determined in this calculator is GCD, the greatest common divisor. That's the equivalent of highest common factor. If you press OK, input your first number, 126. Then we want a comma, that's shift and right bracket, right parentheses. And then the second number, 216, close that bracket and press X. And here we have the highest common factor, 18. Write down all the prime numbers between 15 and 30. We can use the prime factor feature to help confirm if a number is prime or not. So for example, if we input 23 and press Execute, and then Format, and then prime factor, well, that doesn't change. It's not broken into prime factors, so that's showing us that 23 is a prime number. So if we weren't certain, we wanted to check, we could do that. Let's try another number between 15 and 30. 27. Execute, Format, and prime factor. Well, that can be expressed as 3 cubed there. So we know then that 27 is not prime. We can use the prime factor feature to verify if a number is prime if we're not too sure. Okay, a longer question now. Amira invests £5,000 in a savings account she gets compound interest at a rate of 3% for the first year, 2% for each extra year. And part A, work out the value of Amira's investment at the end of 4 years. Let's do this part first before moving on to part B. We're going to stay in calculate mode, but we do need a formula, the formula for compound interest, and I'm going to give that here. Using the formula, we're going to start off with the principal amount, so that's £5,000, multiplied by, well, I'm going to do the full method with the bracket here, 1 plus, and then the rate over 100, so that just changes it from a percentage to a decimal. Navigate right and close that bracket. Now here, with the first year, we've got a rate of 3. Well, the number of years is just 1. So we don't actually have to put a power in there because power 1 is just the value itself there that we've got. It won't make any difference to our calculation. Incidentally, you can put 1.03 straight away if you know that's the equivalent of what we have in the bracket there. And in fact, I'll do that for the second part of the calculation. We've already had that at the first year. We've got at the end of 4 years, that means we have 3 extra years at 2%. So how can we input this? Well, it's multiplied by, well, let's go for 1.02 to the power of an extra 3 years. And we'll press execute to process that. And here's the value of the investment, £5,465.22. We'll round to 2 decimal places as it's a monetary value. Part B then, Leo buys a laptop for £1,200. The value of the laptop depreciates by 12% each year. After n number of years, the value of the laptop decreases below £640. Work out the value of n. There are several different more advanced methods to be able to work this out. But for GCSE and with the knowledge that you have, the best method is a sort of trial and improvement method where we test a number of values of n until we get below the value of £640. Now, the best way to try a lot of values simultaneously is to use table. So if we go to home and then we select table, we should be prompted for fx. Here we go. So what we're going to do is go to function and define fx. Okay, so we're going to input our compound interest formula again here, but with a slight difference. So the principal amount is the starting amount, that's 1,200, multiplied by, I'm going to use the full bracket method here, 1. Now, as it's a depreciation or a decrease rather than an increase, it's a subtract here rather than an add, and then it's 12 out of 100. Navigate right to close the brackets. Now we don't know the year and the number of years that it will take to go below 640. So we raise it to the power of, well, the calculator works in x rather than n. So we're going to just use x instead and just put an x using the x button in that place and press execute. Okay, so now we want to try some values here for x. I'm just going to put in 1, 2, 3, and you can see that the value is decreasing each time after each year. We're not yet below 640, so we'll keep going. 4, 5. You can see after 5 years that the value of the laptop is now £633.27, so it is below £640. So what would the value of n be? It would be 5 years. There are only green marbles, purple marbles and orange marbles in a bag. There are 18 marbles in the bag. Maya is going to take a marble at random from the bag. The probability that the marble will be orange is 0.30. The ratio of the number of green marbles to purple marbles is 2 to 5. Work out the number of green marbles in the bag. Once again, there are several different ways that you can do it. You might prefer a full method on this one. I'm going to use the ratio app in this one and show a method of how you can do this. Bear in mind, this is just one way of solving this. So let's select ratio from the home menu. I'm going to choose the bottom option here so that the answer is going to appear on the rightmost option. Now what we want to input in the known ratio here is we want to connect the amount with the probability. So we're going to have the probability first and the amount that represents. So here we've got 0.30, so 0.3 is the probability, which connects to 18. Essentially, we know both bits of information for orange, the probability of it occurring and the number of oranges in the bag. What are we looking for on the other ratio? Well, on the left hand side it's probability. Well, the total probability is always out of 1, so we're going to keep that as 1. And that will associate then with the right hand side, which will be the total amount. So if we press execute at this point, this will then tell us the total number of marbles in the bag, which is 60. Now that will include the 18 orange, but when we're working out the green and purple, we can deduct the number of oranges from that total within the ratio app. So let's return to the ratio screen. So what we want to think about here now is the last bit of information. The ratio of the number of green marbles to purple marbles is 2 to 5. Well, how many parts are there in that ratio? There are 7 parts altogether. So I'm going to input 7 here. And what's that associated with in terms of amount? Well, that is the green and the purple. Well, we know there was 60 in total, but we also knew that 18 of them were orange. So I'm going to subtract that from the total and execute. 42, so there must be 42 green and purple marbles. What proportion of the ratio was representing green? Well, it was 2 out of the 7. So I'm going to put 2 here, and then X should then reveal how many green marbles there are. And there we have our answer, 12 green marbles. Incidentally, if you are concerned a little bit about working out on the page, I would always suggest putting your working out down. It shows the examiner some evidence of what you're doing, and it's a precaution against, well, just in case you made a mistake and got the wrong answer, there's evidence there for the examiner to see, for you to be able to attribute some marks as you go along. Even if it's as simple as writing these ratios down, it's always worth writing some information. Typically, if the prompt is something such as work out or find, if you find that answer, then you should assume to get all the marks for that particular question, unless there is additional requests such as show all you're working clearly. Here are the ingredients needed to make 12 cheese muffins. We have the ingredients there. Liam wants to make 18 cheese muffins. How much of each ingredient will Liam need? Well, these are very similar to enlargements in some ways, is that you need to find essentially the scale factor. What value would you need to multiply each ingredient by to make more or less of the particular item in the recipe? And in this case, it's cheese muffins. Well, it's what we need, which is 18, divided by what we have in the recipe, which is 12. Let's go to calculate to do this. And it is 18 divided by 12, which is 3/2, or if you just use format and decimal, we can see that's 1.5, which means we want 1.5 times each ingredient. So 240 times 1.5 is 360 grams of self-raising flour, 200 times 1.5, 300 grams of grated cheese, 360 times 1.5, 540 millilitres of milk. And that's the answer to that. M equals 40 minus k squared. Calculate the value of m when k equals -5. Now, you must be very careful when inputting a negative number, particularly when it's squared, so that the calculator knows how to process that calculation correctly. Again, I will just comment, many of you may be able to work this out without a calculator. I will just show you the full calculator method. So let's input what we have. So we've got 40 subtract. Now, if I was going to input a negative number, I would always assume to put it in brackets so that the calculator knows that what you have is a negative number and that you're not subtracting 5. And then -5 we've got in the brackets here. We're going to square that and then press execute. And here we have a final answer then, 15. The price of a necklace increased by 37.5% to £38.17. Work out the original price of the necklace. I'm going to show you two methods of being able to do this. firstly, we could work this out using a division. Now, the trick is if you already have a price that has been increased or decreased by a percentage, what we want to do is to go back to the original price that we have. The starting percentage would be 100%, plus it increases by 37.5%, which makes a total of 137.5%. The price that we have there, £38.17, represents 137.5% of the original price. We've already got that increase. What we want to do is a divide rather than a multiply. So 38.17, I'm going to use the fraction button this time to place the divisor on the bottom, and it's 137.5%. What's that as a decimal? 1.375, and then press execute. And let's go for the decimal price on this one, £27.76. You could also do that in the ratio app. If we select ratio, and once again I'm going to choose the bottom one here, so we know 137.5% represents an amount of 38.17, and that compares to 100%, which is our total, and the amount is, and there we go, let's just change that to a decimal and compare, 27.76, which was our answer then, our original price of the necklace. Here are the times in 10 minutes that 10 children took to walk to school one morning. Work out the mean time and work out the median time. We're going to use statistics again with this one. That should be able to work out the mean and the median for us. So from the home menu, select statistics. One variable, the only variable we've got, is the time that children took to walk to school. So you may have your original data in here. I'm just going to press the delete here. That was from question 1, wasn't it, on that? So if you've got any data, just press delete to remove that. Let's input the times now. I'm going to input the times here. I'm just going to speed this up for time. You take your time to input them accurately. There's all 10 values. Incidentally, with the frequency, you might have noticed that was more than one of some numbers. There was 2 10s, 2 12s, 2 13s, for example. You could input that as 2 12s here and change the frequency. I would just input the original values and ignore the frequency just for simplicity here. But if you wanted to count the number of each value that you've got and change the frequency, you can do. But I think it's just simpler just to input the values that you've got. Once you're done, press execute. And then we want one variable results. And we can see here at the top, this symbol here, X bar, represents the mean. So the mean will be the very first answer that you get, which is 11.9. And we'll scroll down, we'll use the page down here, which is on the right hand side. And you can see here we've got med here, which is the median, and that's 12. So we've got both values there for the calculator. Let's just return. And I'm going to delete the data off. I'm going to try it again. This time we've got a different question. The table shows the number of pages read by 90 students in a week. And we've got groups of pages there, and we've got the frequencies. Calculate an estimate for the mean number of pages read by the 90 students. Give your answer correct to 3 significant figures. This time we will need the frequency column. But what are we going to put in the X column? Well, for our estimates, we're going to use the midpoint of each group. So for example, in the first one, we've got 0 to 20, so the midpoint is 10. If you are not sure what the midpoint is, what you can do is work that out within the cell on the table there. So you can perhaps add them together, the two values. So 20 plus 40, I usually do this in a bracket, and then divide it by two values, and that should find you the halfway point, which is 30. So if you're not sure, you can do that little calculation in there. So I've got midpoint of 50, midpoint of 70, and a midpoint of 90. Okay. All right, down and right, and we can then change the frequency. So we've got 18, execute, 24. Once we're done, once again, it's execute and one variable results. And we can see the mean here at the top. 45.5, looks like 5 recurring there. 3 significant figures, we can give that as 45.6. We'll return again and let's clear out data. The statistics table can also be used for questions similar to this. A factory produces 3 types of component parts in one day. We've got the table there. Work out the mean weight of all 90 component parts, give your answer as a decimal. Well, what we can do with this one is we can input the x as the mean weight of the components, and the frequency is the number of components. So let's input those now. And once we're done, we'll just press execute and one variable results. And once again, we're just reading the top figure there, x bar, which is the mean, 3.4. A printer takes 6 seconds to print 1 page. In total, how many pages can 20 of these printers print in 5 hours? Once again, I'm going to use a ratio for this one because I think it makes it quite straightforward. There is just something to look out for on this one though, so just be careful. So ratio app, again I'm going to choose the bottom one. Next question I will show you one that might use the top arrangement of that, but I generally prefer the bottom one. So a printer takes 6 seconds to print 1 page. Now we're going to have to multiply this up because we've got 20 printers in the second bit of the scenario. So I'll show you how this works, and we'll also use the degrees, minutes and seconds, also known as the time feature, which is shift and plus here to help us out. Now, how would we input 6 seconds? Well, we have to do it in denominations of hours, minutes and seconds. So 0 hours, 0 minutes, 6 seconds. Execute. That will change that to a decimal value for us. So we're relating that to now 20 machines. The rate is 6 seconds per page for 20 printers. How many will they be able to produce in 5 hours? Well, that's 5 shift time button hours. Execute, and there's our answer, straight to our answer there, 60,000 pages. Sticking with ratio, we're going to convert 36 miles into kilometres, use the conversion 8 kilometres equals 5 miles. Well, we've got a figure there in miles to convert to kilometres, so the kilometres would be on the left hand side of the ratio, so I'm actually going to select the top option here and execute. Let's put in the ratio that we know, 8 kilometres to 5 miles. And then we just need to fill in the miles that we have here, 36 miles, and execute. And execute once more to finalise. We've got it as a fraction here. Let's use format and decimal to change that to 57.6 kilometres. Back to calculate. Kian travelled by train and by coach. He travelled 172 miles by train at an average speed of 48 miles per hour. He then travelled for 2 hours and 40 minutes by coach. Work out in hours and minutes Kian's total travelling time. Once again, we're going to make use of the degrees, minutes and seconds, the time feature on the calculator to help us out. We already have the time straight away for the coach part of the journey. We just need to work out the travelling time for the train. He travelled 172 miles at an average speed of 48 miles per hour. Well, the time will be the distance divided by the speed. Let's see how we would input that. 172 miles divided by, I'm going to use the fraction to help me out on this one, 48 miles per hour, so divided by 48, execute. Now what we want to do is to convert this value to a time. So if we just press then shift and then use the time feature, it will do our answer and will display it in hours and minutes. So if we press execute, we can see what that translates to in terms of time, 3 hours and 35 minutes. So to our answer, we're going to add 2 hours and 40 minutes for the coach journey and press execute. And straight away we've got our answer there, 6 hours and 15 minutes. A film lasted 2 3/4 hours. It finished at 21:20. At what time did the film start? We are going to make use of the time feature with this question. I'm going to input the time of 21 hours and 20 minutes. And then we need to subtract the time of, well, that's the length of the film. Slightly unusual way of inputting this. I'm going to input it as it's written. That's a mixed fraction. So that's shift and the fraction button here. 2 3/4. Navigate right, hours. So we want to input the time feature again. 2 3/4 hours, execute. And that will mean the film started at 18:35. That's 6:35 p.m. if we're giving it on the 12-hour clock. Last two questions now, and they are higher only questions. Here are the first 5 terms of a quadratic sequence: 4, 11, 22, 37, 56. Find an expression in terms of n for the nth term of this sequence. We're going to use the statistics app for both of the last two questions here. So if we go to statistics, and we're going to choose 2 variable this time. Just clear the data if you've got any previous data. Okay, so what we want to do, we've got x and y, and again, we're going to ignore frequency in this one. X is going to represent n, essentially the number of the term in the sequence. So we've got 5 terms there, so we've got n of 1, 2, and so on, all the way up to 5. Down and right to go back up to y. Now y is going to represent the terms in the sequence. So 4, 11, and so on. Okay, if we press execute, and then we're going to go to reg results on this one. Now we need to define the relationship between x and y. Now it is a quadratic sequence, and if we have a look, we've got a quadratic displayed here. Now it's slightly different perhaps than what you're used to. We tend to work with ax squared plus bx plus c. We can notice that the a and the c have swapped places, so that's quite important that we recognise that when we're writing in our coefficients for our n squared. So let's select that option, and here it tells us the value. Well, let's start with actually the c. So c is 2, which means it's 2x squared, which means it's 2n squared. Now if I was giving my answer, I would lead with that. 2n squared plus, well, b is 1, so it's 1 lot of n, so plus n. And then a is the constant, the number term that should go on the end. That's 1 also, so plus 1. So our final answer is 2n squared plus n plus 1. Delete the data off there. So another question here, fx equals a times b to the power of x, where a and b are constants. F of 1 equals 24 and f of 4 equals 81. Work out the value of f of 3. So the values inside the brackets of the f function there are the x values. So we've got an x value of 1 and an x value of 4. I'm going to input that into the x column. Navigate to the y column and input the corresponding fx values. So 24 goes with 1 and 81 goes with the 4. Execute once we're done, and we want reg results again. And what we're going to have to do is define the relationship between y and x. Well, it's not on this particular page. What I'm going to do is scroll a page down, and then we can actually notice that it's this second one down here on page 2. The dot there represents a multiply. So y equals a times b to the power of x. So we're going to select that option with execute. And this should tell us the values of a and b, which will help us to find out what the value is for 3. We've got an a of 16 and a b of 1.5. We'll ignore the r for the purposes of this question. So we've got an a of 16 and a b of 1.5. What we're going to do is just move to the home menu and go to calculate and work out what that would be now with an x value of 3. So a value was 16 times 1.5 to the power of 3. And press execute. And there we have the value 54. There we go, some essential skills there for GCSE Maths for the calculator paper. And once again, feel free to use your own method or traditional methods. You don't have to copy any of these, and just remember as well that you want to show working where you can on your exam paper, because the examiner wants to see evidence of what you're doing, particularly if you do make an error and don't get the final answer. There could be method marks that you are able to pick up on there, but generally if the question says work out or find and doesn't request any additional show you're working, then you're okay to use your calculator to the fullest extent that you can, using any of the methods that I've shown you here in this video. Don't forget to like and subscribe for future videos, but that's it for this video. Thank you very much for watching, and I shall see you next time on the Calculator Guide.